Alright, so today me and Ahmed are going to explain the periodic trends and define some terms and why the periodic trends the way they are. So first, let's define some terms. So what is effective nuclear charge? Effective nuclear charge is the attractive positive charge of nuclear protons acting on valence electrons. The effective nuclear charge will always be less than the total number of protons due to the shielding effect. There's a way to calculate effective nuclear charge. It is Zef equals Z to S, Z minus S, where Zef is effective nuclear charge, Z is the atomic number, and S is the screening constant. As you can tell in the nucleus, it is the positively charged nucleus, and then the electron of interest. So in between are the electrons that cancel out the nuclear charge. So basically, this makes them so that the electron isn't like attracted to the nucleus and it doesn't get too close to the nucleus. Second, what is the shielding effect? The shielding effect is basically that the electrons between the nucleus and valence electrons repel each other, making the atom larger. In simpler terms, the valence electrons in the shielding effect can essentially repel any other outside electrons, since they are the same charge. This actually lowers the effective nuclear charge. So the effective nuclear charge and the shielding effect actually work together kind of in a way so that the electrons don't get too close to the positively charged nucleus, as you can see in this diagram. What is the principal energy level? The principal energy level describes the sublevels that the electrons reside in. The s sublevel holds s electrons with 1 orbital, 2 electrons. The p sublevel holds 6 electrons with 3 orbitals. The d sublevel has 10 electrons and 5 orbitals. The f sublevel holds 14 electrons with 7 orbitals, and the orbitals move down as follows: 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s in the diagram I have above. They are this way because of the principal energy level. The first principal energy level holds only S, the second S and P, the third SP and D, and the fourth SPDF, and so on and so forth. So the proton to electron ratio is actually described in physics sometimes. It's the proton to electron mass ratio, mu or beta, is simply the rest mass of the proton divided by that of the electron. So what is the VSEPR theory, aka the valence shell electron pair repulsion theory? The theory states that because electrons repel, molecules will adjust their shapes so that the valence pairs are as far apart as possible, resulting in different shapes of molecules. Some of these look the way they do because of polar and nonpolar charges, because of the electronegativity differences on each side that cause the electrons to cancel out differently. As you can tell in the linear diagram, they are this way because they have the same charge on both sides. But when it comes to pyramidal, the T-shaped, or the V-shaped, it's like this because of the polar, there's different charges on each side. So that's why the electron pairs are spread out differently than normal. So what's atomic radius? Atomic radius is generally just the size of the atom. We will explain the trends in the future slides. So what is ionization energy? Ionization energy is the energy required to remove the most loosely located electron from an atom. What is electron affinity? Electron affinity is the amount of energy released or spent when an atom gains an electron. Electronegativity is the tendency of an atom to attract electrons towards itself. Now for the trends. My partner Ahmed is going to explain the trends and why they are the way they are.
Now for the trends. So what are the trends of the periodic table and the trends that we just explained? Firstly, for ionization energy, why does it increase left to right and bottom to top? When moving from left to right, the number of electrons increases as well as the shielding effect. Therefore, the electrons will be easier to ionize. Thus, the ionization energy decreases down a group. Secondly, for electron affinity. Electron affinity decreases down a group of elements because each atom is larger than the atom above it. Moving left to right, atoms become smaller as the forces of attraction become stronger. The electrons move towards the nucleus, thus the affinity increases. Electronegativity. Because elements on the left side of the periodic table have less than a half full valence shell, the energy required to gain electrons is significantly higher than compared with the energy required to lose electrons. As a result, the elements on the left side of the periodic table generally lose electrons when forming bonds. Conversely, elements on the right side of the periodic table are more energy efficient in gaining electrons to create a complete valence shell of 8 electrons. The nature of electronegativity is effectively described thus. The more inclined an atom is to gain electrons, the more likely that the atom will pull electrons toward itself. Now for atomic radius. Atomic size gradually decreases from left to right across a period of elements. This is because within a period or family of elements, all electrons are added to the same shell. However, at the same time, protons are being added to the nucleus, making it more positively charged. The effect of increasing proton number is greater than that of the increasing electron number. Therefore, there is a greater nuclear attraction. This means that the nucleus attracts the electrons more strongly, pulling the atom shells closer to the nucleus. The valence electrons are held closer towards the nucleus of the atom. As a result, the atomic radius decreases. Down a group, atomic radius increases. The valence electrons occupy higher levels due to the increasing quantum number, which is n. As a result, the valence electrons are further away from the nucleus as n increases. Electron shielding prevents these outer electrons from being attracted to the nucleus. Thus, they are loosely held, and the resulting atomic radius is large. That's about it. Thank you very much for watching, and I hope you have a great day.